Jai Jinendra, Namaste, welcome to my channel. Today we are going to solve the 32nd question of the problem solving series, which is based on binary search. This is the second question of binary search. This question has been asked in Amazon, Microsoft, Apple, Oracle and multiple companies. And the difficulty level for this question is medium. So let's begin. Search in rotated sorted array. So we are given an array and we are given a target element. We need to search this element. And this is a array which is rotated sorted array. So what do we mean by rotated sorted array? So here you can see if here in this example 4, 5, 6, 7 this is sorted, but then again 1, 2 comes. So actually the array was 1, 2, 4, 5, 6, 7 and then this was rotated towards the you can say it is as a left rotation, right? So this was rotated twice, so it became 4, 5, 6, 7, 2, 4, 5, 6, 7, 1. It is rotated again, so twice rotation it became 4, 5, 6, 7, 1, 2. So this is a rotated sorted array and we need to find our target element. So normal search, linear search will give us the answer in order of n, but we need to obviously find it in order of log n. So in this kind of search where the array is sorted though rotated, we will be using binary search. So how will we use binary search to find this target element? We know in binary search we have low, high, and we check the low is the lowest element here, 0th index, high is the n-1 index, and then we search for the find the mid element, and then we see whether the mid is greater than the target or not, and then we eliminate one half and then we search in the next half. So this logic, how will we apply here? Because here one part is sorted and the other part, say for example if we start searching here 4, 5, 6, this is a sorted part, but in the next half 7, 1, 2, this is not a sorted part. So how we will use our binary search logic to solve this problem? So what would be our intuition? What are the observations that we are going to use? So here we need to solve this problem now. So what do? We see our target element is 1 here, for example, and we know that 1 is in 0, 1, 2, 3, 4, 5. It is in 4th index, so target answer would be 4. Here the target answer would be 1. Okay, now how do we apply binary search here? See if the middle element is 0, 1, 2, 3, 0 plus 5 by 2, 2.5, that is 2. So the mid element is 6, right? And now 6 is not equal to 1, right? So now what do? Which part should we eliminate? So we need to see that in this 6 part, this is one part and this is one part. So we can see that 7, 1, 2 is not a sorted part. If we apply binary search here, then we can apply binary search only in the sorted section. This is one logic, that either first every element could be in one of the half, right? So it could be in 4, 5, 6, it could be in 7, 1, 2, and we have our target element. So since the target is less than, this 6 is greater than 1, right? But can we say that since 6 is greater than 1, so our target element must be in the left side? Are we sure about that? Because it might have been rotated, right? If it was not rotated, then it would have been surely in the left half. But we don't know whether it would be in the left half or the right half. So firstly, we need to find which part is the sorted part. How do we figure out whether this part is the sorted part or this part is the sorted part? So if we figure out which part is the sorted part, and then in that part, if our target element lies in that part, then we can apply normal binary search, right? So this is the first case. Okay, identifying which part is sorted part. How do we identify which part is sorted part? When we get the mid element is 6, the first element we know, the low element is 0, the 0th element. So if we check, okay, the 0th element and the mid element, if the 0th element is less than the mid element, does that not mean that this part is sorted? 4, 5, 6, the 4 is lower than 6. So we will be sure if the A low is less than A mid, then the left part is sorted. This is sure. If it is not less than mid, that means the right part is sorted. In this example, the left part is sorted, right? Now here the left part is sorted, we have got, okay. Now once we have this condition, we check, okay, does target lies in the left part or not? How do we check that? If this target should always be less than 6, right? We can see that this target is less than 6, right? This part is sorted, this target should be less than the mid part and should be greater than the lower part, then only it should be lying, or if it is equal, then we will get our answer, right? But it should be less than, right? But is it less than 4? It's not less than 4, right? Though it's less than 6, it's not less than 4. That means we have to eliminate this part, right? So elimination has to be done every time. So if we eliminate this, then from where do we start the search? We make the low as mid plus 1, 7, 1, 2. So this will be our search space now in the second time. If it was there, then we would have applied binary search normally over here and we would have got our answer. So that would be the normal case, but here it's not there, so we'll eliminate and we'll go to this part. So one thing you observe, every time if we are going to this part, if we eliminate this part, then this will be sorted, right? There is just one place where the sorting logic breaks, where we break it, right? Because this part will be sorted again. Okay, now 7, 1, 2. In this part, we will apply the same logic again. We have a new low as 7, this third index, and the high would be same 5th index. And we will compare the is this our mid would be again now changed to this one, and we will compare whether this low 7 is greater than the mid or not. Okay, so we see it's not greater than the mid. So now the reverse. This is not the sorted part. We see that okay, this is not the sorted part. Since 7, 8 is less than mid, 1, 2 is the sorted part, right? So we know that 1, 2 is the sorted part. So in the first case, we were looking in the sorted section. But now in the second case, we see this lows index. The low was 7th, low changed to 3rd index, and high changed to 5th, and mid became 4, and now A low is less than mid. When I'll code it, you'll understand it better. So here in this case, when we see that this is not present, so we'll come to the else part. That A low is not less than A mid. That means this 7, 1 is not sorted. This 1, 2 part will be sorted. And now we will start our search here in this 1 and 2 part. Okay, that we will see since it is not there, so our mid index is this. Anyway, when we find them here in this case, whenever we find the mid would be equal to target. So we don't need to search only, right? Because the low is 3, high is 5, and mid is 4, and we see that A mid is actually equal to A target. So we will get our answer directly. But it could have been that our search space was 2. Then again we would have used that logic, right? So here actually I forgot, the search element target is actually 1, right? So we'll get our answer in the second section only. So for example here, okay, so let me write all the conditions and then we will dry run it for this example. Okay, so what do we do here? We have our n as array dot size, okay, and int low would be 0, high would be n minus 1, while low less than equal to high, right? We will run our loop, and if we have our answer, we will return the answer. If for example we are not able to find anything, then we will be returning -1, which means that the element is not present in the sorted array. Right here in this part, okay. What do we check in the beginning? That okay, if A low is less than A mid, okay. If that is the case, what does this mean? That the left part is sorted, okay. So if left part is sorted, that means if A low is less than AK and AK is less than A high, right? What would this mean? That means, okay, we have these elements over AK is less than A mid, not A high, right? For example, here target was 1 and 4 and 7. So we don't have this, so we will compare this one, right? So if A low is less than A K, which is, okay, not AK, it would be your target element, that is K, right? If A low is less than K and K should be less than mid, then, okay, here we did not write int mid is equal to low plus I by 2, okay? Int mid is equal to low plus I by 2, okay? And here in the beginning we should have written if A mid equal to target, then we got our answer, right? Int mid is equal to low plus I by 2, right? And then if A mid equal to K, then return mid, right? Else if A low less than if A low less than A mid, right? If A low is less than A mid, that means we run the shorted, the left part is shorted, right? That means here we will see if A low is less than K and K is less than A mid, that means we are in the left part, okay? We can search it over here. We will make high as mid minus 1 because then sure the element will exist in this section only, okay? Else if it is not that case, that K is not inside this, for example here it's not there, so then we will make low as mid plus 1, right? Else, that means if A low is less than mid, but if A low is greater than mid, that means this part is not sorted, the other part is sorted, right? Then we will check in the other part, okay? Then what we will see in the other part, if A mid plus 1 or if A mid is greater than AK and AK is less than A high, right? That means the element is present here, okay? If this was sorted, then here our high, our low would become mid plus 1, right? Because our element exists here. Otherwise, if the element doesn't exist in the sorted part, then we will make our high as mid minus 1 because the element is present in the unsorted part, okay? This would be our algorithm, this would be our 4 cases, and we will be able to solve this problem using this logic. So in this way we will be able to solve this problem in order of log n with this 2 observations, right? Checking the low index with the mid index and then checking the target index, where does it lie, and eliminating half of the space every time, okay? So I hope this question is clear, the dry run is clear. The link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section.
Here is the code walkthrough section for this problem. Search in rotated sorted array in the LeetCode platform. So you can see here in the first example, we are trying to find the target element 0 in the array, and we see the index is 4. So it has been rotated thrice. So we use binary search here and we get this. We have already discussed this, so I'll just go through the code section here. Also, I would like to show you that this type of questions are asked in companies like Amazon, TikTok, Microsoft. So it's a very popular question. And yeah, let's discuss the code. So you see we have applied the binary search as I discussed during the problem solving part of the video. And when we see that we have these conditions, we find the which part is sorted. If we find the mid element is equal to target, then we return it. Otherwise we see which part is sorted. So if left part is sorted, then we have this condition: low should be less than mid, array of low should be less than mid, and we see where does the element exist. Does the element exist in this left part or not? If it exists, then we make high as mid minus 1. Otherwise, if it doesn't exist, we make low as mid plus 1. And then again we since this full loop is successful, so we will run the loop and we'll try to eliminate the other half by checking the condition. Say here, if it comes to this condition when right part is shorted, then we follow this conditions inside this condition, that if the element exists in the right part or not. If it doesn't exist, then it goes to the left part again, because every time one of the part will be always shorted, right? So while applying this, eliminating every half every time, so we solve this problem in order of log n using binary search, and whenever the mid is equal to k, we return the mid. If we are not able to find the element using binary search, we will return -1 as it's given in the question. Okay, so let me run the code. So this is being accepted. Let me submit it. I hope you like the solution and the problem explanation. So see you guys in the next video, where I'll be explaining the third question of the binary search series and the 33rd question of the problem solving series. Thank you. Jai Jinendra.